next thing we want to update in our scene is our speed needle, as we want the rotation to accurately reflect the value of the text. If we click on the needle, we can see that we set our Z rotation at -132 degrees, which is the rotation at the lower limit of the gauge. If we set this at 132 without the minus symbol, the needle is at 220, which is the upper limit of our gauge. So we need a way to take a value within the range of 0 to 220 and convert that to a rotation between -132 and 132. So let's go back to our logic. And let's take a look at a new node that does exactly what we want. Let's right click the graph and search for range mapper. You'll see straight away that the colours of the data sockets are wrong, but we can change this in the input and output data type attributes. Let's change these to float now to match our other data. Now, as for the other attributes, we've already established that we want to map a value from an input range to a target range. So let's do that now by setting the inputs from and to attributes to be between 0 and 220. And let's set the outputs from and to attributes, which is the target range, to be -132 and 132. For now, let's leave the clamp attribute disabled, as I'll be discussing clamping later. Now we need to give the node an input and trigger it somehow. So let's create another onChange event listener for our speed value and plug the pulse into the range mapper and the value into its input socket. And then we want to actually set the rotation of the needle, which we can do with the set rotation node. And let's also drag the needle object from our scene into the graph to get its object ID. And then plug this into the object ID socket of the set rotation node. Now you'll probably see that the rotation socket is a different colour to the float data socket. If we try and connect this to the rotation, we will see that it also creates a conversion node. However, unlike previous examples, this node now takes multiple inputs. I explained earlier that each scene object has 3 attributes for scale, position, and rotation. Each of these attributes is broken down into their X, Y, and Z values. In Incari, this is so common that it has its own data type called vector3, which is essentially just 3 floats stored in one container. Looking at the conversion node, we see that by default it has connected the output of the range mapper to the X input socket. But we know from earlier that we actually want to adjust the Z rotation. So let's use Control and left click to move the connection to the Z input. And just a side note, the input sockets which don't receive any data will default at 0. This is okay for our case because the X and Y values never need to change from 0 anyway, but in other cases you may need to adjust all 3 axes. Now, when we play the project, we can see that the value of our speed is accurately represented by the rotation of the needle. We still have a problem though. Currently, the speed can go into negative numbers, and if the value goes out of the 0 to 220 range, the needle rotates beyond the limits of the gauge. To fix this, let's go back to the logic. And right here, before we set the value of the variable, let's add another node called clamp. This node takes an input value and ensures that it is limited to the boundaries of a given range. By providing a from value of 0 and a to value of 220, we can ensure that the speed will never go into negative numbers or exceed 220. Let's preview this to test. So that's all for this lesson. In the next video, we'll be adding some additional assets which we will use to create cool looking effects using the new masking feature.